Welcome to the Clear to Send podcast, a podcast about wireless engineering, where we educate you on Wi-Fi technology, talk about design tips, troubleshooting, interviews, and the tools. Here are your hosts, Roel and Francois.
Hi guys, welcome to a brand new episode of the Clear to Send show. This is Francois, your host, and today we are going to talk about rate limiting. To talk about rate limiting, I have Roel with me. Hi Roel, how are you?
Hello everybody, how are you guys doing today? I'm actually recording in my car, so that'll be interesting because I'm doing this over my hotspot LTE connection.
That's good. Is it warm in your car?
It is now with everything, with my laptop on and all that.
It's pretty cold in my car right now at that time of the year, I can tell you. And we also have another engineer from Canada, Troy Martin, to talk about rate limiting. Hi Troy, how are you?
Hi, doing very well. Thanks for having me on the show.
No problem. It's also pretty cold where you live. It's even colder than where I live, so...
it's minus 16. We got about 20 centimeters of snow, so it's time to hit the mountains for snowboarding tomorrow.
Perfect. Okay, that's perfect. Now I'm jealous.
Lucky.
Yeah. So we invited you, Troy, to talk about rate limiting because you actually presented a TED talk at the WLPC Europe back in October, and you talked about it during 10 minutes. And I actually watched the video and I thought, we could talk about it for more than 10 minutes and expand a little bit on the subject with you. And you just, I invited you and you said, yes, why not? So here you are with us. So why don't you introduce yourself to the audience and let everyone know, what you do, where you live, and how you got introduced to Wi-Fi.
Yeah, for sure. So my name is Troy Martin. I'm currently an SE with one of the manufacturers based in Calgary, but I'm just about to go through a bit of a career change. So I'm going into an independent role where I'll do my own training and consulting with the goal of spreading the magic of Wi-Fi to as many people as possible and educating people just how exactly Wi-Fi works so they can be more successful with their networks, their configurations, and get the performance and user experience that they're aiming for.
That's awesome. I think I have this goal too. But you put it in a nice way, very nice way. The magic of Wi-Fi. Now I want to know, what's the magic of Wi-Fi?
Yeah, it's got you hooked already. So you're going to go fully independent on your own, is what you're saying?
Yeah, that's the plan. Yeah.
Nice. Do you feel scared at all, or you're going to hit the ground running? You feel very confident?
There's a certain amount of risk inherent with a move like this, but there's some wheels in motion. So I think I can smooth out many of the bumps, and we'll see where it goes from there.
Awesome.
There's a lot of opportunities in Wi-Fi, a lot of work out there. So I think it'll be rewarding.
Yeah. Well, I can tell you it's not easy, but it's very rewarding, like you said, and it's very nice, very flexible. So I love it. Hopefully you like it too. Okay, so let's jump right into the subject. Why don't you recap a little bit the main point of your presentation that you did in Prague for WLPC, and then we can just expand a little bit on those points and ask you a couple more questions and exchange on the subject of rate limiting, because it's quite a hot subject among the community. And sometimes it's not an easy subject to deal with, especially when we try to explain how it really works to the customers.
Yeah, for sure. I guess the main driver behind the presentation and kind of what I was hoping to address is a few years ago I had a discussion with one of the customers that I was working with, and they rate limited their network. So they had kind of a 5 meg cap to the center of their network. And the thoughts that were running through their mind is that, hey, if we have this 5 meg rate limit on our network traffic, why not disable all the higher data rates? Because they're not going to be pushing that much throughput anyway. And so this sparked a whole deep discussion on how, there's a lot more pieces going on and why that could cause a lot more harm than they're aware of. But that was kind of the driver for the discussion. So in 10 minutes, I tried to kind of capture some of the highlights collect a little bit of data just to generate some tables there that showed that even though you apply rate limits, obviously the end conclusion of the presentation was that with rate limits, with high data rates turned on, you'll still get those high data rates, but there are other mechanisms in play that'll kind of limit the traffic flow.
So on the Wi-Fi piece, you still get the high data rates, right? If your clients negotiate them with the AP?
Yeah, exactly, right? So Wi-Fi acts as one of the segments as part of your end-to-end communication, and the traffic will flow as fast as it can through each segment, which is one of the reasons that I'd definitely want to have the high data rates turned on, so that you're sending those packets, which need to be sent regardless. But when you do send them across the wireless medium, send them at the highest data rates possible, so that they consume less airtime.
Yeah, that's an interesting discussion that was brought up, because when people say, hey, disable the higher data rates because we're rate limiting them, then why not just change the speed of your ports on your switches down to 10 megs if that's the case?
Yeah, exactly. That'd be the wired equivalent. Absolutely.
So what you're affecting when you rate limiting the on the Wi-Fi, you're actually affecting the throughput more on the network side, right? And you're affecting how long it will take for people to transfer data.
Yeah, well, there's a couple of things at play. So it depends on your application, whether it's using TCP or UDP, and then kind of all the other protocols that are along the segments along the way. But when you start rate limiting within TCP, just the back-off mechanisms within TCP will allow that flow to dynamically reduce the amount of packets it's sending to adapt itself, so it's not seeing packet loss if you're sending too fast and packets are being thrown into the bit bucket. Whereas UDP, you end up with a whole bunch of frames or packets, hitting the bit bucket. But TCP has its adaptive mechanism to take care of that.
Yeah. It's funny because we call it rate limiting, but it's not really rate limiting on the Wi-Fi piece, right? You're still using
yeah.
All right.
Yeah, and I think that was kind of the driver for the question. Is I think that kind of concept was misunderstood. So as part of my presentation, I didn't really go into that, but it kind of goes back years and years to the days of X25 and frame relay. And this is kind of the scenario was a lot of the physical links weren't necessarily very reliable. They had poor connections, shoddy copper, which introduced some physical problems. But frame relay was a faster protocol. And when a lot of ISPs upgraded their X25 network, the frame relay, they were expecting a lot better performance. And frame relay does end-to-end error correction and recovery. So you have to send your data all the way to the far end before you discover something has been dropped or it's been corrupted. Where the advantage of X25, where it did it per segment. So every hop, it was doing error correction and validating that the correct frame was received. And if not, it would trigger a retransmission per segment. Now that allowed it to be really reliable when you had a poor physical infrastructure, but because of all that error correction, it added a lot of overhead. So in theory, frame relay would have been faster if the underlying physical infrastructure had met the requirements. So quickly they realized that was the case, and they upgraded their underlying infrastructure, and then frame relay really took off. But that was kind of one of the things they first observed when transitioning from X25 to frame relay.
Okay, so if you administer Wi-Fi network, why would you limit the rates? Like, what would be a reason of doing rate limiting on your network? What did you hear from your customers, for instance, when you worked for the vendor?
Yeah, and so I think this is more of a philosophical discussion. It kind of depends. You can approach this question from different angles, and it really comes down to what goals you're trying to solve. You could argue that applying rate limiting is more like a band-aid for another problem that you have in your design that perhaps you didn't account for, right? So if you didn't do enough information and requirements gathering to understand all the applications were being transmitted across your infrastructure, and then make sure that you didn't have bottlenecks for those applications. I guess addressing that bottleneck would be the ultimate resolution to the issue. But if you do different reasons, and I talked about a bit about this in my presentation, kind of joking at the layers, 8, 9, and 10. If the financial layer gets involved, where you just don't have the budget to upgrade your internet connection or your WAN connection, some of the levers that you have at your disposal are to apply rate limits. So one of the first things you need to understand is what applications are actually running across your network. And a lot of the infrastructure solutions out there do provide you some insight into those applications. And once you're aware of what's going on and what users are consuming those applications, you can make a decision. Is there business value to transporting this application across my network? Or do I want to outright block this application, or do I want to penalize just the individual users who are driving, the extreme use of this application and driving up my bandwidth consumption? So you can take an action of, rate limit specific users, or do I outright rate limit an application? So you can do it per application, which I have seen good success with. Some of our customers that I worked with in the past, they have sites way up in northern Canada, and so this creates interesting scenarios for them. They have satellite uplinks, and so they may get 1 meg. The really fast sites have a 10 meg backhaul across satellite. So every little megabit or even kilobit that they can squeeze out provides them a lot of savings. So they actually take great effort to limit a lot of applications, a lot of video, social media applications that consume a lot of bandwidth, which frees up the bandwidth for the applications that are legitimate use of their business environment.
Yeah, but I've also seen cases where the company wants to make you pay for the premium Wi-Fi, so they rate limit the free Wi-Fi to something ridiculous. So people get fed up, like users get fed up, and they end up paying for the premium Wi-Fi.
Kind of like a hotel. Hotel environments are popular for that.
Yeah, I've seen that in hotels, in like conference centers and stuff like that.
There's also another aspect to it. On my campus side, it's a little bit political, but we have our visitor network, and that's rate limited as well. But that tries to prevent people that we want to have their devices registered on the campus side, on the school side, and have them use our more secure networks. And if they're accessing secure data, they should be using our protected networks versus a visitor network. That's one of the reasons why we rate limit it, and also have like a splash page every, I don't remember what the interval is, but
every 10 minutes.
You can't. 10 minutes a little aggressive, but if they were to come in the next day, they'll get the splash page again. So it's a little annoying, right? But as a visitor, if you're coming here just temporarily, maybe just for a couple hours, you won't find it too annoying. Hopefully, I know many people don't like splash pages and being rate limited, but that's one of the reasons why maybe in education they would do rate limiting.
Yeah, it depends on the environment. Like if you're thinking about like a public, what I call like a public network, like an airport, a museum, or city. Now users expect to have Wi-Fi, right? A train station, you expect to just show up, or even a coffee shop, you show up and you have Wi-Fi, you connect, it works. And I think like if those places rate limit like crazy, it's gonna affect the user experience. Users are gonna be very frustrated. Because it doesn't meet the expectations, and so depending on the environment, it might be a good idea or not as good of an idea, or you could just do it differently, I guess. Like in the airport, for instance, it would be easier to. From the user standpoint, it would be better to not have any rate limiting, so you can download your Netflix movie before taking off. And do it in like 2 minutes, right? Just making sure the airport just need to make sure, like Troy said, that he has enough internet bandwidth to support all that traffic. But from the user standpoint, it's amazing, right?
I think a lot of it comes down to managing user experience. And anytime you set up a tiered access, I think that creates a barrier to having a good user experience where you want to have that tiered access. I think it's much better to have just a mechanism where it's easy to get onto Wi-Fi, that there's not a hurdle that users have to cross, where they can just connect their devices. And I think going down the road, this is one of the challenges that I think that Wi-Fi faces versus kind of the cellular side. Like I can just turn on my cell phone, it automatically connects where pretty much regardless of where I am in the world. I may pay hefty fees, but my device connects to a phone network. I don't have to go through a convoluted authentication mechanism to get my phone connected. Whereas on Wi-Fi, like every potentially every airport you go to is a different experience. Every coffee shop you go to is a different experience, and it becomes cumbersome for users. So removing the hassle, definitely a way to go. But Roa, I have seen that as well in the education. Is where you want to control what users connect to the network. And so you kind of incentivize them for connecting to more secure networks. Right. And one of the ways you can incentivize them is increasing the rate limit or removing the rate limit so that you get them to connect the authentication mechanism that offers more security, both for your infrastructure and your internal network, as well as for their devices.
So going back to the technical discussion, how does rate limiting affect the channel utilization on the Wi-Fi side? Because we said that high data rates will still be used even though you rate limit the traffic. So how will that affect the channel utilization? What did you see in your testing, Troy?
Yeah, so what happens, because we're still using the same high data rates, none of that changes across the Wi-Fi segments, but inherent into TCP based on the windowing size and the feedback mechanism from the endpoint, the TCP flow detects that it's losing some packets. So it tells its source, the device that's generating the TCP flow, it tells it to slow down, stop sending as many packets. So you have fewer packets that end up being sent end to end. But when those packets cross your Wi-Fi segment, they're still sent at the high data rates. It's just the packets aren't coming as fast, out of your client or across your access point. So if you kind of compare this to duty cycle in a sense, when you turn on rate limiting, the amount of frames going through the airwaves, the duty cycle of those frames, it decreases. And that effect of that, it takes longer to send your information, just because it's fewer packets are being sent over a given period, but when they are sent at a high data rate.
That's interesting. So the channel utilization will be lower, but the clients will be sending information for a longer period of time.
Exactly.
Okay.
Yeah. So in the airport scenario, right, if you're trying to download your movie, like you're frustrating users if you're artificially putting on a rate limit where they're not necessarily contending with other stations, other devices in the airport. And they could download that Netflix video in 2 minutes. You put some frustration in the users where they may have to abort 90% downloading their video because it's last call to get on their plane.
Yeah, when the airtime maybe was free for them to do it faster if they didn't have any rate limiting.
Yeah. Another example we saw is I did some work with a large service provider up in Canada, and they had that 5 meg rate limit on their devices, and they went through an exercise of, hey, in one of their municipalities, what if we remove the rate limit? What's going to happen? And there was a lot of concern and fear that if they took away that 5 meg rate limit, that they were just going to get blasted with traffic from all their devices. And once the rate limit was removed, they found that there was no noticeable increase in the amount of traffic generated by their devices.
That's interesting. So that's a use case you could reuse for other customers, right?
Yeah, so this is a massive kind of carrier-grade Wi-Fi network, tens of thousands, hundreds of thousands of client devices, and they didn't see a noticeable increase in traffic. And part of that is because it's bursty in nature, but also mobile devices and the applications they run, they do a very effective job of kind of compressing in the codecs that they use. They don't necessarily need a lot of bandwidth, although that is changing a little bit just based on the weight of video applications that we're seeing.
There's also a lot of buffering, and when you stream video, when you stream audio. Okay, so let's talk about some guidelines. Okay, so let's say I want to disable rate limiting. What do I need to be careful about?
If you're turning off rate limiting?
Yeah, let's say I have it active right now, like 5 meg, and I want to turn it off. What do I need to be careful about?
Yeah, one of the first things I'd recommend having in place is some sort of tool set that lets you gain visibility into the applications running across your network, so that you can kind of do a baseline of what's going on today. And once I make that change, what happens following that change? Do I see spikes in all user traffic across the board? Do certain applications start spiking? Is there no net difference? And then once you understand the delta, then you can make an intelligent decision on, hey, am I good with the net effect of removing rate limiting? Or was there something that I didn't expect to happen and now I need to take action against that? Maybe just rate limit those specific applications, maybe have a conversation with users to better understand how they're using those applications. But getting knowledge of what's going across your network is the key step to making any changes with rate limiting.
Because you might have a scenario where the since you disable rate limiting, you start seeing users using the Wi-Fi a little bit more and generating more traffic. And then if your internet pipe is not big enough, you might have an issue there. You might have a new bottleneck now.
Potentially, yeah, you might have a new bottleneck, and then you got to take action. Do you increase your net pipe? Do you turn on QoS so you can prioritize applications appropriately, and maybe that addresses your issue? Or maybe you start rate limiting certain applications, or take action against specific users who are really pounding your network.
Yeah. Okay. So what type of, you mentioned some tool sets to get some visibility. What do you have any specific example of tools you could use, or is it different per vendor?
Yeah, so there are a lot of third-party tools that you can use. Many of the manufacturers, the vendors out there right now, built into their solutions, they give you or provide visibility into those applications that are running across your network. So a lot of them, you can just use the built-in tools that you'd get already with the product.
Okay, yeah. So you go on your controller, on your dashboard, and then you check what type of traffic is going through your network, and you try to evaluate the quantity and the type of traffic.
Yeah, there's like operational dashboards that you can look at that kind of break it down, the top applications, in the last hour, 24 hours, that kind of thing. The top users, how much bandwidth were they consuming, on what types of devices. You can see if the traffic was bursty, steady streams. And once you have that insights, then you can start taking more intelligent action.
Okay. All right. I think we already talked a little bit about that with some of the example we talked about. But when would you recommend using rate limiting on the Wi-Fi network?
I guess when you run into kind of a financial bottleneck where you're not able to increase your internet pipe, essentially, because that's where your bottleneck
the satellite
comes in.
Connection.
Like, unless you. Yeah. That'd be a prime example of that. It's extremely cost prohibitive to augment the satellite bandwidth capacity. And so their only resort in that scenario was to apply rate limiting. And it ended up being very successful for them. So they have a very long laundry list of applications that they block, and they constantly do a review and they monitor what applications change. So as different social media applications come in and out of favor, they modify and tweak their list.
That's interesting. Okay.
Yeah, there's other tweaks you can do too, just for video applications. Like you can set rate limits so that you don't allow, 4K or high def video, but you allow standard to go through, and then the application will dynamically adapt to get the best performance for the user based on the throughput that application sees. So you can kind of game the system a little bit for some applications that way as well.
That's cool.
And that's done with like the advancement of some of the management platforms, right? Because that'd be, I would imagine, pretty difficult to do if you just have, say, a router on the edge and there's not much that you can control in saying only allow standard def versus high def.
Yes, you'd have to do some analysis just on the application and kind of roughly how much bandwidth it was consuming, and then set your rate limiting thresholds to kind of hit those thresholds. Yeah, I'm not aware of anyone that can just say, hey, standard def versus HD and just block it that way. It's more kind of gaming with numerical rate limiting thresholds.
Oh.
Yeah, so you really do have to have the data to say what's on your and we're talking just when would you use rate limiting? So if you could use simple open source tools to track what kind of applications are going through your network to determine, okay, maybe I should rate limit YouTube videos. But a lot of I would say like the cloud management APs now, you could do layer 7 application throttling, which is very useful indeed, especially if you're sharing your bandwidth pipe with your regular users and also your visitor, your guest users.
Yes.
So you maybe want to make sure the guest users don't exceed your pipe there, and then make your actual mission critical applications come to a halt.
Yeah, I see that being useful in like a hospital, right, where you have patients getting on the guest or the patient network, and then patients out there for weeks, and they end up bench watching Netflix, right? And they'll be using a lot of bandwidth.
And that's where maybe the business requirement is you want to allow those guests to use Netflix, right? And you just need to design your network to support that. But if it is becoming an issue and you do decide to turn on rate limiting, I think dropping packets as close to the access layer as possible is a really good way to go about it. So if you can drop it right on the access point, definitely do that.
All right. So rate limiting is still beneficial, right, in some situations, right? So it's not like black or white, as always, I should say.
I wouldn't think so. You need to look at your business requirements and make sure you're addressing those, and then take action that kind of follows out of those business drivers to come up with a technical solution that supports the user experience that you're going for.
Yeah, you just have to be aware that if you have rate limiting on and you're not careful on how you do it, or if you do it too much, you might have a poor, user experience.
Absolutely, and I think a lot of people overlook that. Rate limiting definitely impacts user experience. So any chance you have to avoid rate limiting, that's the path I'd recommend going down.
All right. Okay. Do you want to add anything, Troy, to the discussion? Do you want to share some experience or anything?
No, there's some of the stories that I've come across I've shared already in the podcast. I think just because you can rate limit something doesn't mean you should. If you put on like your security hats, it's only allow users to access applications, resources that they should have, and block everything else kind of by default. It's a different model where if you want to create a very simple and intuitive user experience where people simply pull out their device, turn on their Wi-Fi card, or turn on Wi-Fi on their mobile device, they can connect easily to your device and use the applications that they want to use. It's a much better experience for them. Like if you flat out block Netflix and all people want to do is use Netflix on their mobile device, their interpretation is your Wi-Fi network is broken. There's very often little feedback to the end users. That if you're doing a full-on rate limit or significantly throttling application, the user experience is this application doesn't work, and they translate that to your Wi-Fi doesn't work. Wi-Fi is broken, which is a common scenario that we see.
Yeah, I agree with you. It depends on the scenario, on the network you administer. I think for most of my customers, it's they see rate limiting as a way to avoid the scenario where guests will take over the Wi-Fi, right? Because at the end of the day, they're still using the same channel, right? They're still on the air. They're still sharing the same air time, so they don't want the guests to take over the Wi-Fi. But if your business is like a public venue or airport or any places like that, coffee shop, where users expect to have a pretty good Wi-Fi connection right off the bat, I think you just have to be aware that if you don't do it properly, or if you do it too much, you're gonna have a lot of angry people, and that might reflect to your business, right? If a lot of people come to your coffee shop and they have poor Wi-Fi experience, they might not come back, right? Or they might tell their friend, "Don't go over there. They have good coffee, but their Wi-Fi sucks. So if you want to get some work done, that's not the place to go," right?
Yeah, and we have worked with some schools in the past where they'd submit RFPs, which is one of the things that hopefully you get a chance to get in front of the customer and have a discussion, whiteboard some of the behaviors of Wi-Fi and run through the math with them. But the RFP was asking for a solution that satisfies requirement. We have 30 per classroom. Each student has 2 devices, and we want each device to support 10 megs simultaneously of throughput.
Wow.
Which is extremely high requirement.
Yeah.
Right. It's extremely. And so they're concerned about saturating the Wi-Fi, and they're concerned about the Wi-Fi being overdriven. You have a conversation, get down to the question like, well, what's your internet backhaul or your backhaul out of your school sites, right, to your centralized data center? Like, we have 100 meg pipes at the majority of our schools. Well, in this scenario, like your bottleneck is your upstream link.
Yeah. How did they come up with a 10 meg per device, 2 devices per person, 30 in a room?
Well, I think that the
good question.
The 30 students per room is pretty standard, so that was pretty easy number to come up with. So interesting. They assumed that they'd have 1 device, 2 devices per student. But the reality was they had a lot of schools had 2 carts, so they'd wheel a cart of 30 computers in and out of the classroom. So at any given time, there would only be 2 classes that could potentially be 30 devices. So you're looking at 60 devices across the school, not 60 in every classroom. So a much different actual user scenario than what they were describing in their RFP, which if you just met their word for design a network to meet their goal, there'd be significantly more access points in their deployments. There'd be a lot of directional antennas being used to control the RF propagation, which would be a significant kill for what they. I personally believe a lot of users don't know, or administrators don't know the applications that are running across the. And that's why they come up with these numbers that I need 10 megs per device. It's because they just don't realize how much actual throughput and what applications are actually on the network. They don't have that insight.
Yeah, and if they measure it, it's probably way less. They just don't know about it, right? And they just I mean, we do that for 2-dimension network, wired network as well, right? We tend to over-dimension the network all the time.
Mm-hmm.
All right, Troy. So
it's a common problem.
Yeah, common problem on the Wi-Fi means a lot more access point, like you said. Anyway, okay. So just to conclude, I would invite everyone to go on YouTube and watch your presentation. It's pretty funny too. You always find some jokes. I don't know how you do different jokes every time for your presentation. So it's 10 minutes. It's on YouTube. You just search for Troy Martin WLPC 2018. You'll find it. You also did a presentation on Wi-Fi security, I believe. That was pretty awesome too. Just go over there.
I just kind of broke down just how AES works.
AES works, yeah. It's actually pretty cool. That's not something you dig in every day. It's nice to see how it works. So if you're interested, just go on YouTube and you'll find the videos. We'll also put a link in the blog post on the Clear to Send website, cleartosend.net/157. Troy, where can people find you online?
I'm. You can reach out to me on LinkedIn, of course, Troy Martin, or I'm also on Twitter @TroyMart. So those are probably 2 of the best places to get a hold.
Okay, perfect. Well, thank you for coming on the show. Good luck with your new business adventure. I'm sure everything will be fine. You're like the best Wi-Fi guy in Canada, so you'll be on demand, I think.
Oh, thank you, Francois. That it means a lot coming from you. And thank you, Ruel and Francois, for having me on the show.
Thank you, Troy. Thank you, everyone, for listening. If you want more information, we'll add the details in the show notes, cleartosend.net/157. And we'll see you next week for a new episode. Bye-bye, guys.